Hello, this is Ms. DB. In this video, we are going to solve quadratic equations with square roots. But first, we're going to review how to simplify square roots. We've done this before in this course, and you'll need to do it again in geometry and algebra 2 and so on. So we're going to look at how to do that, and then we're going to identify when you can solve quadratic equations by taking square roots. It only works on some of these quadratic expressions, and then we'll solve those. So, simplifying square roots. There are numbers called perfect squares that when you take the square root of them, you get an integer answer. Like the square root of 25 is 5 and negative 5 because 5 squared equals 25 and negative 5 squared equals 25. Those are called perfect squares. And there's a whole lot of them. There's the square root of 1 is equal to 1 or negative 1. That's a perfect square. That's the first one. So the square root of 1 equals plus or minus 1. The square root of 4 is equal to plus or minus 2. The square root of 9 is equal to plus or minus 3. And you should recognize these because knowing what they are will make it easier for you to do this worksheet. And we did the square root of 25. I'll just write it down anyway. And we have the square root of 36 is equal to plus or minus 6. Square root of 49 is plus or minus 7. Square root of 64. Square root of 81. Square root of 100. And let's go one more. 121, the square root of that is plus or minus 11. So these perfect squares are what we will be looking for as a factor when we simplify our roots. So, for example, square root of 20. If we use a calculator, we get a decimal approximation. It's not an exact answer. The decimals would continue, and we can't find the exact answer for the square root of 20. It's a good enough answer many times, but in math, if we're going to use this calculation any further, we want the exact answer. So here's how we do it. We take the square root of 20, and we find factors of 20. Well, the factors of 20 just means what times what equals 20. Well, 1 times 20, but that doesn't get us anywhere. 2 times 10, 4 times 5. And we want to try to use the factorization that would have at least one perfect square in it. And that would be this one. Because 4, right here, is a perfect square. So we rewrite square root of 20 as the square root of 4 times 5. We just replace 20 with 4 times 5. And there's a rule that says we can break this down now. If you have the square root of a product, you can rewrite it as the square roots of both of those products multiplied by each other. So the square root of 4 times the square root of 5. And we know what the square root of 4 is. The square root of 4 is plus or minus 2. We have it right up here. So we would write plus or minus 2, and the square root of 5 cannot be simplified, so I would just rewrite it, and that is my simplified answer for the square root of 20. There will be a negative and a positive answer. I can find that plus minus sign if you're typing. You can find it by inserting a symbol, but you can also write it, just write plus 2 square root of 5 and negative 2 square root of 5. Some of these will be perfect squares already. Some of these are up in this list. Some of them you will have to simplify. I think I'm going to start number 5. I want to show you how you would write this if you were typing it. So let me give myself a little more room. Move it down here. All right, so to start with, the square root of 20, I want to rewrite that as the square root of its factors. So what times what equals 200? There's so many. There's 4 times 50, and one of those is a perfect square, but 50 can still be broken down more. What about 100 times 2? That would be good because we know the perfect square of 100 is 10. So I can just use SQRT for square root and then put parentheses around what I am taking the square root of. Now I could have wrote 2 times 100, but then the perfect square is after the other one, so it's better if you can put the perfect square first. So now I'm going to rewrite this as the square root of 100 times the square root of 2. What is the square root of 100? The square root of 100 is 10. And it's really positive 10 and negative 10. Let's find a way to write that without having to insert. There's the positive part. I'm going to put the slash key, then I'm going to put the negative. That will work. So I have plus or minus the square root, or plus or minus 10, because I'm going to take the square root of it, times, and for times you can write the asterisk, or you can just write square root of 2. Now if I was writing this by hand, I would write square root of 100 times 2, which is the same as square root of 100 times the square root of 2. And the square root of 100 is 10 plus or minus, and then I need the square root of 2. You don't need a times sign between these two because writing a number next to a square root means you're going to multiply. So these are both the same answer, just one's typed and one is written out. Either one is fine. But do make sure that you write a plus or minus. If you want to do it in 2 steps, like say 10 square root 2 and negative 10 square root 2, that's another way of doing this. Either of those would be a good way to write it. All right, next we're going to look at quadratic equations that can be solved by using square roots. I said earlier that not all of them can be, only sometimes. And the sometimes part is when you look at the standard form, ax squared plus bx plus c, like we looked at last week, if there is no b term, so if b was 0, it would just be ax squared plus c, that's when you can use square roots to solve. So it's not just if there's only 2 terms, because it has to be the x term that's missing. For example, x squared minus 9. There's no b term, there's no x term, there's no b here. That can be solved using this method of square roots. Here's another example, 9x squared plus 26. There's no x term. Here's one that's not an example, 9x squared minus 16x. That will not work because it's not the x term that's missing. B is not 0, b is negative 16. This one will not work. So it doesn't have to just be any term that's missing. It has to be the b term is 0 so that there's no x term. So for 6, 7, 8, 9, 10, you're going to write yes or no. Which one of these could be solved using square roots? So be careful. It's not just if there's 2 terms. It's that if there's 2 terms and there's no x term. So there's a couple of those that would not be able to be solved by using the square root method. You only have to write yes or no. Do not have to solve those. All right, now we're going to look at the steps that we are going to take in order to solve quadratic equations using the square root. Here's our steps. Step 1, replace y with 0. Sometimes it would be replacing f of x with 0. If it says f of x equals, x squared minus 9, you replace y or f of x with 0. And you can, usually I write the 0 on the right side, just for, I like it the way it looks that way, but you don't have to. Then you are going to rewrite with the x squared term on one side and the constant on the other side. So what does that mean? It means this in this example. I replaced y with 0, so I have 9x squared minus 81 equals 0. Now I'm going to add 81 to both sides. So I get 9x squared equals 81. Now I'm going to solve this equation, simplify it as much as I can, which means I'm going to, I move this over a little bit, I'm going to divide 9 by both sides. When I divide 9, these cancel, and I'm left with x squared equals 81 divided by 9, which is 9. Now I'm ready to take the square root of both sides. That's the key to this problem, is that I can solve this by taking the square root of both sides. The square root of x squared is x. And the square root of 9, there's 2, there's 3, and negative 3. And that is how we would solve this problem. Now we can check by graphing. We can graph this, and the quadratic should go through 3 and negative 3 through the x-axis. So number 11 has been all set up for you, almost solved, and you just have to finish. So what you're going to do in 3, the next step will be divide both sides by 4, and then the last step will be to take the square root of both sides. Let's look at number 15. Sometimes you'll have to simplify the roots when you're done. You won't get a perfect square. So our first step is to write this equal to 0. So instead of equal to y, we want it equal to 0. The next step then is to add the constant to the other side, or subtract sometimes, so that you do not have so that you can simplify farther. So we get this. Now I want the x squared by itself, so I divide by 3. That cancels, and you're left with x squared equals 50. Now this is where we end up taking the square root. This is why we are doing these. We're going to solve by taking the square root. So when you get down to just x squared by itself, then is when you can take the square root of both sides. So I'm going to, let me get another color here. I have x squared equals 50. I'm going to take the square root of both sides. And the square root of x squared, those undo each other, and you're just left with x. And the square root of 50, all right, square root of 50. It'll be plus or minus, but we need to simplify this. So, square root of 50. That could be rewritten as something times something. So let's look at the factors of 50. I have 5 times 10, but neither of those are perfect squares. I have 25 times 2. Oh, and that's a perfect square. So I'm going to rewrite square root of 50 as the square root of 25 times 2. The square root of 25 times the square root of 2, I can rewrite that now. And what is the square root of 5? The square root of the square root of 25 is 5, and it's plus or minus, and then the square root of 2 cannot be simplified. So x is equal to plus or minus 5 times the square root of 2. And remember to write the plus or minus. There will be 2 solutions to this. So there are a few of them that you'll have to simplify the answer, the root, instead of getting a perfect square that when you take the square root of it, you get an integer. Just a couple of them that you have to do that, but that's good practice. I see I have that on number 14. It says the same thing. But most of them, when you get down to the end, you'll be able to get an integer answer. All right, so let me know if you have any trouble with this, and we can work on it together. Thanks a lot and have a wonderful day.